Well then, welcome back. I have just a couple of slides and then I will switch gears to example 2, which is using Mplus. And I had put all of the code and the output in a handout so that we could go through it more quickly, but if you'd like to run things with me, all of the original files are inside the download under example 2. So we have 5 different input files and output files, as well as the 2 corresponding models that are available in lmer and the data set that goes with it. So I like to have the handout so that everything is sort of side by side, but then if you want to run the things on Mplus, that would be fine as well. So let's see here. So we had some lovely foreshadowing before break about the idea of doing implicit centering. So that's what I want to show you how to do and what the resulting parameters then mean. So picking up then on slide 36 of lecture 2 for just a couple of slides. So this is where we were this morning, the idea of centering level 1 predictors using the level 2 person mean. That is depicted graphically here. The idea is that we are representing between person mean differences with an observed variable for the person mean, as well as within person fluctuations or deviations around those person means with a level 1 variable. And both of these have to be treated as observed if you are using what I would call a univariate multi-level model. So that means one outcome rather than having multiple outcomes simultaneously, one outcome over time. Whereas on the y side of the model, the variability at level 2 in the means is represented with an estimated random intercept, whose variance is then found by the model, as well as an estimated within person residual variance for level 1. So there is a symmetry in what happens on the predictor side with the outcome side, but the variables are treated differently. So we can fix it if we're willing to switch software. So basically transitioning from boxes for your time varying predictor into circles. So camera 1, camera 2. So this is the idea of what is known by several different words. Latent centering is one term that you can use to describe this. And it's just the idea that we are going to let the program partition the variance in a predictor in the same way that it partitions the variance in an outcome. So from the point of estimation, both of these variables are in the likelihood and being treated as outcomes. Both of them have distributional assumptions of multivariate normal then put on them, and both of them can then have data that are missing under an assumption of missing at random, which is conditionally random. So we have latent centering is one word for it. The latent covariate approach is another term, and this is where most people would call this type of model a multi-level structural equation model. I prefer the term multivariate multi-level because there is no measurement model per se. We're still ultimately working with an observed x and an observed y. So we have, let's see, here are some words that distinguish sort of the pros and cons of different approaches. So if your time-varying predictors do not have individual change over time, then you have a choice as to whether you want to do person mean centering in a univariate framework where x is represented with observed variables versus latent centering in a multivariate framework where x is represented by latent variables instead of observed. And so one of the pros of doing it this way is that both variables are treated the same. Simulation research on contrasting these two models has suggested that the level 2 relationships that you get back, if you allow x's variance to be partitioned by the model in the same way that y's is, are actually stronger, which makes sense because you're not treating the person mean as a perfectly reliable observed variable. You're letting it be latent. And so the same benefits that people typically talk about for structural equation modeling would be obtained within this context as well. However, because the model has to also estimate the level 2 variance in x for person mean differences, it's going to have a harder time doing that in data sets where there's not very much mean differences and where there's not very many individual occasions with which to extract the mean. So if you have an intra-class correlation for your X time-varying predictor, say less than 10% or so, then the results that you get back are going to be a lot more variable because it's going to have to work harder to figure out what the random intercept variance part would be than if you just created an observed person mean. So you can always make a person mean. You can't always necessarily estimate a corresponding variance component within a multivariate model. So you'll end up with greater inconsistency, higher standard errors potentially, in situations where there's not a lot of information at level 2 with which to estimate the between-person variance and corresponding slopes. Some of the downsides of using this multi-level latent centering multivariate version is that if you're within structural equation modeling software, which is the only way to do this, it doesn't have REML and it doesn't use denominator degrees of freedom, which means that in small samples, your variances are going to be too small and potentially have more type 1 error in their associated fixed effects. The other piece of it is interaction terms. And so in the example that I'm going to show you, if you want to look at moderation, so this is very often the case where you might want to see if the between-person effect is moderated by some other variable, and if the within-person effect is moderated by some other variable. That's very easy to do if your predictors are observed. If your predictors are latent, then instead you have to estimate latent interaction terms. And that requires a different method of estimation that's known as numeric integration. It's the same idea as what makes IRT models difficult when you have multiple dimensions of theta at the same time. The other piece of it is what you get out of your level 2 slopes varies by the software, the syntax, and the method of estimation. So can I tell you another quick story about these models? So there's a paper here that I wrote essentially as a rebuttal to a paper that was published that made me so angry and frustrated that I had to write a paper about it. Have you ever had that experience? Like you read something and you're like, no! And then you just have to type it out. So what happened is Mplus, the creators of Mplus, published a Teacher's Corner article in SEM in which they were showing the benefits of their new Bayesian estimation in Mplus relative to maximum likelihood. And in particular, the difference was that they now had the capacity to estimate, come on dude, random slopes for level 1 predictors within this latent centering framework. And they described the results of a simulation where using maximum likelihood, they got one set of numbers, and using Bayesian estimation, they got a different set of numbers, and the Bayesian estimates were closer to what they should be, and therefore they described the maximum likelihood version as biased. But if you read the fine print, do you know what happened? In the maximum likelihood version of the exact same syntax, the level 2 effects became contextual effects. And in the Bayesian version, they became between effects. So the same exact syntax with 2 different lines for what estimator you're using create 2 different sets of results. I know. And that was maddening enough as it was. But then they had the audacity to say that the maximum likelihood version was biased and incorrect because it didn't have the between results. It's like, no, they're contextual. One's a linear combination of the other. And so I pounded out a paper in like a week of this, and I had my own simulation to show that, yes, you get the correct answers once you make the switch from between and contextual. So that's the paper that is linked here. There's a table in it in particular that shows all the different ways in Mplus that you can specify a model that has level 1 predictors with random slopes, and whether you get between effects or contextual effects or a mixture of both depends on your estimator and how you write the syntax. So that's one of the things that I want to show you today, because even people who know exactly what they're doing find this really confusing. Big nod, yes. So, and the only reason that I was able to figure this out at all is because I had simulated data where I knew what the answer should be, and it wasn't coming back right until I figured out that what it was giving me was a contextual effect, and then I could make everything match up. But Because this is confusing and somewhat inconsistent and software is continually changing with respect to what you get, I wanted to show you how the different ways will result in different things. But basically the discrepancy that they were writing about is between versus contextual with respect to what level 2 means. Okay, so with that prelude in mind, I have an example for you. This is example 2 in your download packet. I have the original data and all of the source files for Mplus and R in there. These data are featured in chapter 8 of my textbook. So these are real data. They're not simulated, but they've been doctored a little bit to help create a more interesting story. The story is trying to examine mediation among 3 variables, stressors, so whether or not a stressor happened on a given day, and I believe we have 5 days worth of data here, negative mood on that same day, and physical symptoms. So like, do you have a headache? Do you have a tummy ache? Do you have, basically a laundry list of things? How many of those things do you have where higher scores mean that you're feeling worse relative to what you would normally feel? So the first thing that I want to point out here is this classic mediation kind of triangle. Have you seen this sort of thing before? The mediation triangle where x goes to m goes to y? I got 2 of them. This is not redundant because when each variable in the mediation triangle is measured longitudinally, I have the potential for between person level mediation, which would be the cross-sectional part among the means, as well as within person mediation separately at level 1, the idea of more or less than usual. In this example, everything is concurrent, so there's no lagged effects here. The example 3 will have some lagged effects to try and get at that sort of temporal ordering process, but this one is all concurrent. So because of the limitations of what can be done with respect to maximum likelihood, I ended up treating stressors, which is a dichotomous variable, as observed. So that's why stressors is in a box. So I'm going to have the level 1, 0 or 1 version, the dummy code as to whether or not a stressor happened each day, as well as the person's mean for the proportion of days that had a stressor. And it's been centered at 0.4, which represents 2 out of the 5 days as sort of my reference point for what 0 on that person mean variable is going to mean. Now in the middle, negative mood is both an outcome of stressors as well as a predictor of physical symptoms. So this is an instance in which there is really no way to get lmer or any other univariate MLM software to do this, because each variable in lmer is either an outcome or a predictor, but not both. Whereas in this type of model, I need them to be both simultaneously. So I am going to be using latent centering for negative mood so that the model is figuring out how much of its variance is between persons due to mean differences as a random intercept. So I've got tau squared u with a subscript of m for mediator, and how much of its variance is level 1 within persons, so sigma squared e for m. So I have x, m, and y as part of my labeling convention so we can keep the roles of the variables straight in our head. And physical symptoms is the outcome that would be partitioned into what is level 2 random intercept and level 1 residual either way. So the new piece of the puzzle is really this middle section right here. How do we set it up so that we have a latent variable as a predictor rather than an observed variable? Okay, questions or comments on the story so far? Yes?
You centered the stressors on the, no. So what is this person means with the higher left square? The right person means stressors?
The level 1, yeah, so the level 1 variable of stressors is not centered. It's at 0-1 dummy code. But then I also still included the person mean of stressors at level 2. Is your question, why did I do that? Or... Because without this box in the level 2 model, what kind of effect of stressors would I get?
Smushed.
Yep. It's smooshed for me, but I will take smushed. Yeah, that's an alternative pronunciation. I also accept smooshed as another version with the 2 O's. But yeah, this is why. If I haven't extracted the level 2 variance out of that stressor dummy code, then its effect is smooshed. So more formally, a smooshed effect is assuming that the within level slope of stressors predicting mood is equal to the between level slope. And alternatively, another way to say that is that I'm assuming that the contextual effect for their difference is 0. That there is no additional impact of being someone who has stressors more frequently after I control for whether or not I had a stressor today. I'm assuming that doesn't matter. Okay, does that help clarify? All right, other questions on the story or the setup? So for the purposes of pedagogy, I'm going to show you sort of this global model in layers. We're going to start with one piece at a time so that you can see how the code changes and how the interpretation might change based on what has been included. So it's 5 days of data for 105 older adults for these 3 variables, each measured repeatedly over time. And then I have words here describing my rationale as to how I'm treating these things, basically summarizing what I just said. There are 2 different ways in Mplus of specifying level 1 effects in the syntax. One of those ways is if you only want a fixed effect. The other way, using placeholder syntax, allows you to also have a random effect as well as cross-level interactions. But when you switch to that second way, all of your level 2 effects become contextual. So I will show you what the result is and how to get the between effects back as linear combinations. So here is step 1, and I have contrasted side by side the exact same model using lmer as I have in Mplus. These are equivalent. I have used maximum likelihood estimation in both, so we will get the exact same answers. So the first piece of this is the x to y path before controlling for the mediator. So the whole idea of mediation is that the relationship between x and y will differ after you control for m if there's mediation to at least some extent. It is not the case that the path from x to y has to be significant to start with. The only criterion is that it's different before than after. So this is the before. Stressors predicting physical symptoms at level 1 and level 2. So in lmer, let me make this a little bit bigger here. This is what it would look like. Symptoms is my outcome. It's predicted by my fixed intercept. I have controlled for gender, age, and their interaction, because this example is following a previous chapter where we learned those things predict physical symptoms. And then the new part with respect to stressors are these 2 variables right here. So in this case, because stressors is dichotomous, I opted to leave it alone at level 1, and I'm adding in person mean stress centered at 0.4, so that's what the 40 means. That means what I'm going to get back is the within slope effect from stressors and the contextual effect from the person mean. So to figure out what the between effect would be, I have to add them together. The way that I can do that is with this contest1d function. This is out of the lmer test package, I believe. And the order of these values here goes with the order of the fixed effects in your model. What these values are multipliers. So we saw this at the end of yesterday. This is how I can ask the program to estimate a linear combination of the model fixed effects so that I can create the between effect as the sum of the within effect and the contextual effect. So the way that I would read this is the first 0 means don't use the intercept. The next two zeros mean don't use the slope for gender or the age slope. The 1 means take the slope for stressors. The second one means add it to the slope for person mean stress. And the 0 means don't use the interaction of women by gender. So it is literally adding the two slopes together, estimating a standard error for it, and getting a significance test as well. So even though I'm setting up my model as a within effect and a contextual effect, I can get back to the between person effect that's going to be more directly interpretable. Okay, questions on any of that code or concepts? Thumb sideways?
I think I'm a bit confused why, for instance, we do not assume a random slope, or am I just not interpreting it correctly?
There is no random slope, you are correct. All that I have in this part of the model is a random intercept. And partly for that reason, let me back up. In this particular data set, the random slopes were not needed. So I would have, earlier in the chapter, I tested the need for it with the likelihood ratio test, decided we didn't need it, and so I left it out. But that also, if I had included it, I would not be able to show as many permutations of the model because then I'm locked into only one kind of syntax. So it's both a pragmatic decision and what this particular data set warranted. But you are correct, there's only a random intercept. Okay, other questions? So here is the exact same thing in Mplus. So I've put all of the code here so that you can see what the setup would be. So I have example2.csv as the file that's being used for these analyses. Here's the names of all the variables in the data set, and note that I had to shorten some of them to meet the 8-character restriction. Use variables is all the variables that are currently going to be in the analysis. That includes several variables that were already in the data set plus one new one. So in Mplus, you cannot define an interaction term on the fly like you can in every other GLM package. So this term right here is an interaction in R. I can't do that in Mplus. I have to make it. So here is another new piece of code you haven't seen yet, the define statement. And that's how you can make new variables for your analysis. So I made a new variable that's called age sex, which is literally the multiplication of age centered at 80, which was near the mean, and the gender variable in which men are 0 and women are the 1. So I add that to the end of the use variables list. And so note my comment here, it will yell at you if you change the order. Newly created variables have to go last. This is a long data set, by the way. So it's 5 rows of data per participant. Missing data values, identify my cluster, level 2 ID variable. Then stress is being treated as a predictor that is observed only at level 1. So I would call this stressors, but I'm going to run out of letters. Whereas age, gender, their interaction, and person mean stress are observed predictors only at level 2. If you forget this, what it will try to do is put a variance in the other level, which may break it if there is no variance there. 2-level random, maximum likelihood estimation. So this method of specification we saw earlier today, but in the context of time. So here's the same method in a context of time-varying predictors. So I've got my within model. Symptoms is when I write the word by itself, creates a variance. So what that word refers to is the level 1 residual variance for symptoms over time. The regression of stress predicting symptoms at level 1, I am defining a placeholder for, so it's kind of like the beta 1 and the level 1 equation is what I've created, and I have named it within person X to Y for my own sanity. So X is stress, Y is symptoms. Then at level 2, I have the fixed intercept for symptoms, the random intercept variance for symptoms, and then these two new things. So in brackets, that refers to the variable's fixed effect. When I list the variable by itself, that would refer to its variance. And the fact that it is at 0 means that I am not estimating a random slope variance for it. So this is a fixed effect only that I have included. And I have labeled it so that I can do math on it. So when you see something in parentheses, it is doing one of two things, potentially both at the same time. It could be a constraint, like we saw this morning, how I had resvar for all 7 of the residual variances in that line. Typing one word for 7 terms holds them equal to each other. In this case, I'm not placing a constraint, but I am labeling what this fixed effect is going to be so that I can do math on it. So down here then, I have also labeled the 4 regressions of the simple main effect of women predicting symptoms, age predicting symptoms, age-sex interaction predicting symptoms, and then person mean stress predicting symptoms at level 2. And I have labeled that with a con in the front indicating a contextual effect because that's what it's going to be. Then to do math, I can use model constraint. Have you seen this before? Mplus users, a few people? Okay, good. So you can do lots of things in model constraint. I'm using it to literally add the slopes together. So this piece right here, where I'm saying, make me a new term, I'm going to call it between person x to y, and it is to be created out of the within person slope plus the contextual slope. So that piece is directly the same as this linear contrast right here. That's what it's doing. Okay, questions on any of that? Yes.
Sorry, I'm very disturbed. I don't know if you...
I'll try not to take it personally.
Really sorry. Why can't we put stress on both levels? Or is it because it's a dummy variable?
Yes.
If it was a continuous variable, would you just simply put it on both levels?
I could, and that's what I'm going to do with mood in just a minute.
Oh.
So I tested this. When I initially built this example was probably 5 or 6 years ago, and at that time, you could not allow stress to be partitioned if it's categorical. That is still the case if you use maximum likelihood. But if you switch to Bayes, then you can.
So this is the right input for my published. Now I understand.
Okay. Inside, there's a folder in your download packet for this example called Extra, because I thought this question would come up. So here is the version of the model in which we have latent stress instead. Let me zoom in on this so we can see it. So I've taken stressors out of the within statement and person mean stress is gone. I've switched it to estimator equals Bayes, and I'm estimating I get a stress variance at level 2 because even though it's categorical, I can still have a random intercept variance for it at level 2. I do not have a residual variance for it at level 1 because it's a Bernoulli distribution that doesn't have a separately estimated variance. And likewise, I don't get a mean of stress, I get a threshold, which is the logit of the probability of a response of 0, not 1. I hate thresholds. I hate them with the fire of 1,000 suns. I don't know why they do this to you. I just say multiply it by -1 and it's an intercept. Then you can think of it as regular. Here's a typo I need to fix with a 0 there. I remember this thinking that, the reason the $sign is because if you figure out what a threshold is, someone will pay you. So yes, this is what it would look like to do it as latent stressors instead, which is probably preferable. But here's the thing. I am not great at Bayes. I am still working my way through Bayes and learning about the impact of priors and stuff. And there has been some research on the effectiveness of the default priors that Mplus sets, saying that they're suboptimal in some cases. So because I don't know very much about priors and their impact, it makes me hesitant to just trust all I got to do is say it's Bayes and it's fine. So because I'm not doing a good job of explaining all those other pieces, I hesitate to like put this out there as this is the answer. But this is a way to do it. But then the onus would be on you to make sure it has actually converged and all of that stuff that you would have to do additionally. Whereas maximum likelihood converges onto one thing that you should be able to trust. Sure. Does that answer your question? Excellent. Do I get bonus points for having an extra, for anticipating it? Yeah, I was like, wait a minute, I bet it can do it by now, because this is, 6 years old or something. And it can, but not in maximum likelihood. So this is an example of a model that can be done equivalently in lmer as in multivariate MLM, because we're treating X as observed, sort of the big picture. So here's what we get back out of lmer on the left-hand side of the screen. And here's what we get from Mplus on the right-hand side. So we can try to map the numbers onto each other. So first up, here's my log likelihood. That shows up over here, as well as AIC and BIC in smaller is better forms. Log likelihood is in bigger is better. Within level residual variances for symptoms is 0.6 and some change. That's right here. Then we get down to the regressions at level 2. So the effect of gender, age, and their interaction on symptoms is here, here, and here. Those all match. The regression of person mean stress as an observed box predicting latent symptoms is right here, and that matches this one. So the way I would interpret that is for every unit change in person mean stressors relative to other people, symptoms on average is expected to be higher by 1.3. So people who have more stress have worse symptoms on average. The only catch to interpreting this coefficient is to think about what a unit is. This variable is a proportion that ranges from 0 to 1. So a 1 unit change corresponds from somebody who never had a stressor to somebody who had stressors every day. So to be more realistic, you might move the decimal over and then say for every 10% more stressors you have, your average increases by 0.13. So you can end up with some very weird coefficients because a unit is the entire span of the variable in that case. Okay, so next up, what have we not hit yet? The effective stressor right here, that's my level 1 within person effect. So then for every unit more stressors I have, and you can think of this as the difference between 0 and 1 after controlling for my person mean, then I am going to have worse symptoms that same occasion by 0.11. And let's play Where's Waldo. Do you know that thing? It's like a search. I like to play Where's Waldo with statistics. So let's find that coefficient in the Mplus output. Where is it? 0.110. This thing. It is described as the mean of the latent variable that I created right here. So this is my fixed level 1 effect. It does not have a variance. That's where its random slope variance would be if I estimated it, but I shut it off. And then here's my fixed intercept for symptoms. We hadn't hit that one yet. That's my expected symptoms for someone with reference values of all the predictors. And here, this one. What's that? Residual variances for symptoms at the between level that's 0.8. That's the random intercept. So this is residual because they mean left over. So you'll note there's two kinds of residuals because they're both left over. But there's level 1, what I call residual, and then there's level 2, what I would call random intercept for symptoms specifically.
And the fact that it's significant hints to the fact that there are some random slopes hiding.
No, this is random intercept.
Random, and the other one was random.
Yeah, so the proper way to test whether this value is greater than 0 would be a likelihood ratio test. I can tell you, eyeballing it, yes, it's going to be. So the interclass correlation is greater than 0.5. There's no way that's not going to be significant. And then last but not least, if I take 0.11 and I add to it the contextual effect of 1.3, I get the between effect of 1.4. So I'll put words on each of those values to help us along. This is the within effect. It talks about the result in symptoms at the same occasion for having a stressor versus not. This is the between effect down here. This is the effect on average symptoms for having 1 unit more average stress. But after controlling for whether or not you had a stressor that day, then that coefficient is reduced to 1.3. So the contextual effect is controlling for whether or not you had a stressor that day. The between person effect is not. Said differently, this contextual effect right here, which is significant to at least 3 decimal places, is your proper hypothesis test as to whether smushing is okay. It is the difference of how the between effect differs from the within effect. If that difference is significant, they can't be the same number. I think we got through all the numbers. I didn't do these ones. Do you want practice with interactions? You feel good about those? Yeah. This is the gender difference in 80-year-olds. Women are lower. This is the age difference in men. Older people have more symptoms. And this is how, let's go, the gender difference changes in older people. It looks like the gender difference becomes more negative as a function of age. So there's a bigger difference between men and women who are older than between men and women who are younger. That's what this means. And that is all in chapter 7. Okay, questions, comments?
Horrible, but I have another question.
Be that person. That was me. I had my hand in the air every 30 seconds. So yes, be that person.
Maybe it's relevant for your studies also. I'm just thinking again about this stress, the dummy stress, and I'm thinking sometimes we do these multi-level vignettes. Like vignettes are nested within person. People do read, I don't know, 5 vignettes, and in the vignette then we have a manipulation. Let's assume there was a manipulation which was dummy. You read, you were in the control variable condition or in the experimental condition.
Okay.
1 to 0, just like stress here.
Okay.
Would you still center it on the between person like you did here with stress?
Did everybody get an equal number of control vignettes and treatment vignettes?
Yes. Anna? Yes.
Then you do not need to worry about smushing because your vignette variable is only within persons. There is no between person variance in that dummy code if everybody got the same number of each. In the same way that yesterday, I didn't worry about this at all for time because everybody had the same 6 occasions. There was no between person variance in time, which means there is no between person effect possible which means that I can't possibly be smooshing because my level 1 variable only has within person variation in it. In the same way that I don't have to worry about smooshing the effect of gender or age, which in this study are time invariant because they only have level 2. So yesterday there was a clear demarcation of only, and today there's a blend. My son is eating Indian food. My son only eats like 4 things: chicken nuggets, pizza, macaroni and cheese, and anything involving cake. So this is quite an event, let me tell you. He must have called it cake. That must have been what. We're going to have some red cake and some yellow cake, and that's what we do to tell him to eat things. We call it food that we know he'll eat. Anyway, how are we doing, folks? Thumbs? See, what time is it? 1:38. Not quite time for a break just yet, I don't think, unless we need one. Doing okay? All right. I have my proprioception of when it's time for a break, when everyone's head is down and does not come back up. That's the part that you don't get on Zoom class, right? Because everyone's in the black box. You can't tell whether they're checked in or checked out. So I miss in-person teaching for the feedback. All right. Any other questions about just this model right now? Yes.
You explained it like ages ago, but I think I just realized that it's still not clear for me how
Fair.
this person mean helps us to then, was it actually important for the contextual? No, it was for the between person effect. I think you needed this. I still don't really get the idea behind it.
Okay. So the idea is, for the same reason that you need a multi-level model to predict your outcome, because there's multiple levels of variation in it, you need to worry about that with respect to multi-level predictors too. It's directly the same idea. So in this model, we are operationalizing the idea that there's level 2 random intercept variance in this stressor predictor by putting its person mean in the model as a separate effect. And then the stressor level 1 part is just the within part. But because the stressor has not been centered, it's just 0, 1, it still has its between person variance in it. The way that this model is phrased is such that you end up with a within effect of stressors, but a contextual effect of person mean stressors, and you have to add them together to get to the full between person effect. Does that help at all? A little bit? Pictures? This is the picture that goes with that idea. Because stressors is a 0, 1 variable that still has person mean differences in it, it's going to account for random intercept variance. The person mean part of it is going to. We add the person mean in so that we get the extra piece to get to the full between level effect. And I chose to do it this way because stressors was a dichotomous variable and it doesn't make sense to person mean center it as much as just to leave it alone. But for mood, we would have choices as to which one we want to do. But to keep the models parallel across lmer and Mplus, I'm going to treat mood the same way. Okay, other questions or comments? Okay, then here is the next one. So we know that there is a relationship, let me see here. I haven't looked at the significance yet, because I just want you to know what the numbers mean. I trust that you can use the dichotomous p less than 0.5 or not, because that part hasn't changed. So this is not significant. There is no effect on symptoms at that occasion of having a stressor that day. But it is the case that people who have more stressors than other people report more symptoms than other people. So here is the M to Y piece. So just looking at whether or not mood and symptoms relate to each other bivariately. And here, the models are not going to be equivalent because in lmer, I am forced to use observed predictors for mood, whereas in Mplus, I'm going to use latent predictors instead. So the purpose of this side-by-side comparison is to see how the results differ when you do it one way versus the other. So now symptoms is the outcome, as before, and I have mood centered at 2. So it's a Likert scale variable. So 2 was near the mean, so that's what I picked for the constant. And I also centered person mean mood at 2 as well. So the reference point is somebody who reported a 2 on this day and whose usual level is a 2. Over on the Mplus side, mood 2 is the only variable that goes into the model. I'm not going to use person mean mood because instead I'm going to let it do latent centering, where it splits up the variance in mood into level 2 and level 1 as latent variables rather than as observed predictors. So mood 2 is the only variable that goes in. There's nothing in the within only model because mood needs to be in both. And the only between level variables are my time invariant predictors of age and gender from before. The within model then, I've listed symptoms right here as before because that refers to its level 1 residual variance, so the within person fluctuation in symptoms. And to get the same thing for mood, I just list it too. I have centered mood at 2 so that the fixed intercept stays meaningful, by the way, but that is otherwise not relevant to the story. The prediction of symptoms from level 1 mood, I have defined a placeholder for, and I'm calling it within person M to Y. At level 2, this is the fixed intercept for symptoms. This is the random intercept variance for symptoms. This is the fixed intercept for mood. This is the random intercept variance for mood. So what I have done then is this picture. X and Y are being treated the same. So I don't need person mean anything because I'm not trying to represent level 2 variance with an observed variable. I'm letting the model do it as a latent variable, the same as I would let it do for Y. Okay, does that make sense conceptually, what's happening? Maybe. Ish. Thumb sideways looks, that's what it looks like to me. So you can think of this as a multivariate model where I have 2 outcomes. I have mood and I have symptoms. It's just that one of the outcomes is going to predict the other. Because they're both outcomes, I can have missing data. Because they're both outcomes, I have to assume multivariate normality unless I specify otherwise. Then we get into this part. That is the fixed effect of how level 1 mood predicts level 1 symptoms. And I have shut off its random slope variance again as before. Here are the same regressions of sex and age predicting symptoms as before. And then here is the level 2 relationship, which is a contextual effect, mood 2 predicting symptoms. So previously this was person mean whatever. Now it's just the original variable, but the part of it that I'm referring to is the level 2 random intercept part as a predictor. This thing right here is a predictor. It's just that it's latent instead of observed. And as before, I can create a between level effect by adding the within and the contextual together. So here are the estimates from lmer, where I'm treating mood and person mean mood as observed variables. here are the corresponding estimates from Mplus on the left-hand side. So there's a couple differences here in what is a model parameter and what's not. In the lmer output, the mean and variances of mood are not model parameters because mood is a predictor, it's exogenous. Whereas in Mplus, the mean and the variances of mood are model parameters that have been estimated. So the level 1 relationship between latent mood, so it's analogous to it's analogous to constant base centering, is right here, 0.167, and it was 0.159, so relatively the same. Not significant, by the way. So if you are grumpier than usual today, you're not sicker than usual today. The level 2 relationship is 2.5 if I use latent variables, whereas in lmer it's 1.97. So this demonstrates what a lot of simulation research has suggested. You get a stronger between effect if it's between two latent variables than if you try to represent the predictors' mean differences as an observed variable instead. And significant. So people who are grumpier are sicker. And then, yeah, there's the between, there's the within, and this is the contextual, this one right here. I don't know why it's not bolded. Yeah, put that there.
And these are people who are grumpier or sicker, considering today's grumpiness.
So this one that I have highlighted right now is the contextual effect. This means that people who are grumpier are sicker even after controlling for how grumpy you are today. So another way to think about it is that like how you are the rest of the days matters. Like you is the context. I have a paper actually where the title is something like persons as contexts, trying to describe the way that these models are set up because that's what's happening in this situation. And this bottom coefficient is without controlling for how grumpy you are today, the between effect. And it came from within plus contextual. One more variant on this model, and how about we take a break? Does that sound good? Moving over to the right-hand column. Given that the within level effect is fixed only, I have a choice in how I write the syntax to estimate it. What I have done up to this point is first define a placeholder, then refer to its mean and variance in the level 2 model, which is how you have to do it if you want to have a random slope variance for a level 1 effect, and or if you want to have a cross-level interaction predict that random slope variance. Here's an alternative that's simpler. You, if you only want a fixed effect, can write the code so that the within level fixed effect is directly in the within model without a placeholder. So I have labeled what it's going to be because this is just a within level regression. What happens is that then the level 2 model switches. What you get at level 2 instead of the contextual effect directly is now the between effect. What did you say?
I didn't know all these things.
I know. This is, I initially figured this out when I was writing my book, and so this went into chapter 9, but then after they put that paper out saying that ML was biased, I was like, no, it's this! What you get in your output now when you try to fit models with the random slope is a warning that says if you want between within decomposition, you need to switch to base. It's the syntax that allows for the random slope. What it treats as the level 1 variable is not the within part, it's the whole thing. So this mood right here refers only to its residual variance, predicting the residual variance of symptoms, which is directly analogous to person mean centering instead of constant centering. In Bayes, it's consistently within person, both cases. So this is a between-within version where you can get the contextual effect if you want to as their difference. And indeed, the results directly match across the two. So now my level 1 relationship is up in the within model. It's still 0.167, which is what it was over here. The level 2 relationship right here is the between level that we had defined as a linear combination before. And the linear combination of their difference for the contextual is what we used to get at level 2. This isn't confusing at all, is it? Not at all. So why does it matter is trying to make sure that what you're talking about is the level 2 relationship is between versus contextual. Either way, the level 1 is the same. Question?
Yeah, just to be sure, if I have the version on the left-hand side and I have the slope with the stakeholder thing, it only affects the between level results. So I have contextual results on the between level, but the within level should be fine.
It depends. Again, the reason that these are both okay is because I have controlled for the contextual effect in the model right here. If I didn't have this, then the level 1 effect that you would get over here would be smushed.
And then to report the model, I would always calculate the between, the whole between effect and not report the contextual effect.
It's up to you. I have a much easier time talking about between within as more than other people, more than usual. The end. More than other people after controlling for what you have today is more of a mouthful and harder.
But I'm actually not interested in the between level results, so my model is only on the within level.
Okay.
But I'm interested in only on the within level. But I think I accidentally reported the contextual effect on the between level.
You would be in good company.
Yeah, I think we all do it actually.
Wenn Knuten does it, then
Yeah, this is not well understood, honestly, because there's so many permutations in how you set up the code, and it just got even worse when it's ML versus Bayes gives you literally 2 different solutions for the same code. So where it can get tricky is like if you have a negative contextual effect, that does not mean that more X leads to less Y. What that could mean is that the between effect is not as strong as the within effect. And that's a completely different interpretation. So in the 2019 paper, in the discussion, I have some example pictures and sort of what would it look like if you misinterpreted one versus the other and what the difference would be in that situation. But the only way, again, that I figured this out ever is because I had simulated data where I knew what I should get. Question?
I'm just interested, did they ever respond to your papers, or sometimes you have kind of this reply to, you know?
No, because I didn't phrase it that way. I sent it to a different journal.
Okay.
It was the new APS methods journal. And I tried to be more diplomatic in how I phrased it, as this is what they said, but an alternative perspective would be kind of like alternative facts, which is a catchphrase for lying in our country. The way that they approached it, I thought was really disingenuous, and it set me off. But then as I was getting into the paper, I realized just how confusing it was. And I thought, if I have to work this hard to figure this out. And this is what I do for a living. Like, what chance do people who this isn't their primary focus have? So trying to help. But what is true now may not be true a year from now if they update the software and make other changes. So it looks like they've pretty much stopped developing the maximum likelihood side, and they're putting all of their focus onto the Bayesian side. So if you run everything in Bayes, then this between versus contextual problem goes away, because everything that they do is analogous to person mean centering in latent space, where everything stays consistent as between versus within. But then you have to worry about convergence and all the extra stuff that you do with Bayes. Okay, time for a break? Yeah, let's take some time, regroup, and maybe like 15, 20 minutes, somewhere in there. Does that work?